Hi, I'm John, and this is my video about DevOps and Agile. In this video, I'm going to be giving a run-through of DevOps and Agile. So I'm going to start by giving an overview of DevOps and some of the key concepts of DevOps and the technical elements and the tooling that we use around DevOps. And I'm going to be diving into the continuous concepts, which is more around the culture of DevOps and how we approach different areas such as testing, delivery, deployment, integration, monitoring, etc. And then finally, we're going to be exploring the Agile methodology, which is the project management approach that is an alternative to the traditional waterfall approach of software delivery. So let's start by looking at DevOps. So what is DevOps? Well, DevOps ultimately is the adoption of culture, practices and tools to efficiently deliver software iteratively. So it's important not to see DevOps as a technical thing in and of itself. Technology is, of course, an important part of DevOps and the adoption of DevOps, but culture and practices are also key to its adoption, changing our behaviour and the way we think and approach our work. So if you're new to DevOps and you come into it for the first time, it's quite a significant paradigm shift in the way that we work and the way that we work in our team and what teams we're maybe a part of. So if we think of the more traditional approach where we're working in silo teams, IT operations, development, quality engineering and security maybe, working in silo teams, we pass things off to each other between the teams and we work in isolation. To start using a DevOps approach and working in a cross-functional team where we have people with all those different skills working in one team towards one common goal is a very different mindset. So this is why culture is a very important part of DevOps. Adopting technical tools is an important part, but it's not all of it. So ultimately, it's an evolution of traditional IT and software development practices. So as I mentioned, silo teams, DevOps aims to bridge that gap and bring the development team and the operations teams, quality engineering and security teams all together to work towards a common goal. So as I mentioned, DevOps is a shift in culture, and it advocates for collaboration between the traditionally siloed teams, and it advocates for shared ownership, responsibility and objectives. Another key component of DevOps is automation. From all aspects of our software delivery, from integration to testing, deployment and the infrastructure provisioning as well. So fast and consistent deliveries with reduced manual errors. So a key concept of DevOps is to deliver software quickly. A more traditional approach, we might have been releasing the software in one big bang once a quarter or once a month maybe. DevOps encourages continuous integration, much smaller changes, keep those code changes coming in, keep those automated tests running, and then there's less risk of issues that way. So then, as I mentioned, around the teams, and I was joining IT operations and DevOps development teams together towards a common goal. Infrastructure as code plays a key part of that. So when we think of our cloud environments, if we're using AWS, GCP or Microsoft Azure, we use infrastructure as code to define what our infrastructure should look like. So we've got our application code. We store this in code repositories. We might have automated processes around delivering the application. The infrastructure is the cloud resources that underpin that application. And these, in a more traditional on-premises environment, this infrastructure would be things like virtual machines, the configuration of the operating system, the things that the central IT teams typically responsible for. So in a cloud environment, all of these resources still exist, that underlying infrastructure, but we can define it in code. And this is typically a file or multiple files that say we want this resource, we want it configured in this way, we want it to have this number of CPUs, we might want it to be replicated to another data center in a different country. There's a whole host of different things we can configure, and we can define that in code. And part of DevOps is also to put that code into our Git repositories and have automated processes around deploying the infrastructure that underpins the application, exactly as we would for the application code itself. So we've got the IT operations team with their infrastructure as code and the development team with their development code following very similar processes. And this is a good example of how DevOps brings development and operations together. So putting infrastructure as code gives us Git history and versioning as well. So that's one of the key benefits of infrastructure as code. When we've got traditional what is called ClickOps, which is when we go into the cloud portal, which might be the Microsoft Azure portal as an example, and make changes to fix issues, we have no record of what the changes were or why they were done. By using Git and Git repositories and having the Git history, we've got a record, and we could potentially even be linked off to work items like user stories or tasks that give context around what the change was for, what was the business context, where did the requirement come from, etc. Exactly as it would with application code. And another key benefit of infrastructure as code is consistent and replicatable environments. So often creating another environment, if we've got a production environment and we want to create a dev environment from that, it can be almost as easy as copy and pasting code. There will be modifications between different environments, but typically it's going to be a lot easier than if you imagine you deployed a production environment manually through the portal and then you want to recreate that environment. It's going to be quite a tough task to recreate it exactly, whereas infrastructure as code makes that super easy. So next area to mention is toolchain, and this is the technical tools and technology we use to facilitate DevOps. So many tools and services are catered to a DevOps methodology. We've got GitHub, Azure DevOps, GitLab and Jenkins, and these are known as CI/CD tools. They also often have project management capabilities plugged in as well. So stuff like work items, we're going to get more into Agile later in the presentation, but ultimately a lot of the work that we're making, the code changes to the application, stem from requirements that are defined in the project management layer. And these tools often provide both the project management layer and the technical tools, bringing the processes and the technology together. Then have Kubernetes. So Kubernetes is a container orchestration service. So if you're familiar with containers, it offers another layer of virtualization for our application, allowing us to virtualize the OS and run multiple applications in isolation on the same machine. And Kubernetes is an orchestration service that provides a lot of capabilities around containers. Now, Ansible, which is a open source tool that allows us to define in code how we want our operating systems to be configured. So infrastructure as code, is the example I gave earlier, defines the Azure resources. So this is, or the cloud resources. So this says, what does the cloud infrastructure look like? Ansible is an example of a tool that can define what you want the inside of your virtual machines to look like. Terraform, ARM, and Bicep are examples of infrastructure as code tools. So Terraform is a multi-cloud infrastructure as code tool. It can work with Azure, AWS, and GCP. ARM and Bicep are native tools to Microsoft Azure. And then Prometheus Metrics, which is a monitoring capability. So now let's look at continuous concepts. So continuous concepts are as you become more familiar with DevOps, you'll see a lot of these mentioned frequently. So these represent a paradigm shift towards an iterative, adaptive, and automated approach to delivering software. So these are the kind of the processes or concepts that we follow throughout our work in a DevOps culture. And it is an alternative to seeing development, testing, and deployment as distinct sequential phases. So historically, when we're developing an application, which I'm going to get more into later in this presentation, but we would work through a number of project phases, from gathering requirements to design, delivery, testing, and then deployment. And then we'd work for those stages sequentially. And DevOps is about an iterative, adaptive, and automated approach. Instead of working sequentially, we're following these 10 continuous concepts throughout the application lifecycle. So now what I'm going to do is drill into each of these. So just to point out what they're called, we've got continuous integration, continuous testing, continuous delivery, continuous deployment, continuous security, monitoring, feedback, discovery, documentation, and improvement. So in the next slides, I'm just going to give a quick overview of each one. In each slide, there's a comparison table. I won't call out all of the comparisons because it would take quite a long time. But if you like, you can pause the video and you can have a look at the comparisons. What we're going to compare is a traditional approach to software delivery and then a DevOps approach. In this example, we've got continuous integration. So continuous integration is the concept of frequently merging our code into the main code base, typically multiple times a day. So traditionally, we would do this a lot less frequently. It would be one big update that we would do in one. We'd apply a lot of changes in one. And this was quite risky. And if there was issues, if we do a release every 3 months and new requirements have come about, 1 month into that cycle, we're not doing another release for another 2 months. So we can't adapt quickly to the market or to the customer requirements or the user requirements. Continuous integration means that we integrate code frequently, all of the time, really small changes, a lot less risk that come from those changes as well. And it promotes more consistent and reliable code because we're making those frequent changes. Issues come in, present themselves quickly. And with a traditional approach, we do one big change. If we have a big issue, it might be a lot harder to figure out what about that change has caused a bug or a problem. So we've got, three integration mechanisms. So with traditional approach, distinct integration phase after development. So as I said, with that sequential process we had, integration was a phase in its own right and it came after the development. In DevOps approach, we're doing integration, testing, and we're doing all of these things on a daily basis. And so feedback timing, delayed feedback after integration tests for a traditional approach, immediate feedback on issues for a continuous integration approach, debugging duration longer due to accumulated changes, as I mentioned, continuous integrations, quick resolutions due to those small changes, process consistency, often manual, leading to potential inconsistencies, and with continuous integration, we're automated, ensuring consistency. So then the next concept is continuous testing, and this is around how we perform testing, when we perform testing. So execution of automated tests continuously through the software development cycle. So those CI/CD tools, things like GitHub, Azure DevOps, Jenkins, they typically have built-in mechanisms for us to run tests, stuff like unit tests, integration tests, functional tests. They have mechanisms to run automated processes that will run our tests. So when we're integrating our code frequently, daily, we're running those tests constantly, and as soon as an issue comes up, we'll see it. We won't be able to proceed with any deployment or anything. So that issue will announce itself. Immediate validation maintains software quality. So with a traditional approach, it was again another phase in the process. We'd do development, then we would do testing. So we'd do a lot of development and then we'd do testing. So we would be more likely to find issues in that approach compared to doing frequent changes. With automation, manual testing is predominant in the traditional approach, whereas with our continuous approach, we're heavily reliant on automated test suites. Feedback timing, delayed feedback after test cycles in traditional approach, immediate feedback for continuous testing. The scope of testing is selective testing and might not cover all aspects every time for a traditional approach. So when we're doing continuous integration and we're running unit tests, we've potentially got thousands of unit tests that we can run. Each are going to take milliseconds. So very quick feedback and very comprehensive feedback, and the same test run every time as well. And then integration with development, often a separate phase after development in traditional approach, tightly integrated with development and CI/CD CI processes with continuous testing. Okay, so now we have continuous delivery, and continuous delivery is again another automated concept. It's around automatically preparing our code for production release after passing the build, test, and staging. So as you can probably see already, a lot of automation evolved in DevOps, and we need automation to follow the message that DevOps has of doing these continuous, rapid integrations. We need automated testing. But the continuous delivery ultimately is about getting our software ready for release, and it ensures that software is in a deployable state during any stage of the life cycle. So frequency of releases is a traditional approach. It could be monthly or quarterly. Continuous delivery, potentially multiple times per day. Automation, manual with traditional approach, automated with continuous delivery. Feedback timing, feedback after releases, often delayed with continuous delivery. Rapid feedback loops, immediate insights, post-deployment. Large releases with traditional approach because of those less frequent changes. Smaller incremental releases with continuous delivery. Stakeholder involvement is limited with traditional approach, whereas we get the feedback throughout with continuous delivery. Deployment risks are of course higher with doing big changes like we would with a traditional approach. And the rollback mechanism can be complex due to the larger change sets, whereas they are simpler with continuous delivery. So the next concept we have is continuous deployment. Continuous deployment goes one step beyond continuous delivery. So continuous delivery is about preparing the software for release and giving us a package that can be deployed at any time. Continuous deployment is about actually deploying that to production, and it's about doing it automatically without human intervention. Now you see on this table, there's a lot of similar elements with a traditional approach and continuous deployment approach. Very similar to the previous slide, due to the size of these more traditional, when using a more traditional approach, the size of the changes that we're making, carrying more risk, and the potential for issues, we have the same problems with continuous deployment. So then we have continuous security. So continuous security integrates security practices and processes into the DevOps workflow. So another process that we're doing continuously throughout the application lifecycle. It's an integral part of continuous integration, delivery, and deployment, and it's not something that's completed at the end. So with a traditional approach, we would typically have a separate stage again for security and enhancing security, possibly at the end of the project once it's been developed. Continuous security says that we do that through every iteration of the application. All of those changes that we're integrating frequently, daily, we're doing security as part of that. So frequency of security check-ins are periodic security audits and reviews for a traditional approach. Security checks are integrated into the DevOps pipeline, so another automated process with continuous security. And feedback timing, we get feedback after audits and after breaches. We definitely get them after breaches for sure. That's with a traditional approach. Immediate feedback during development and deployment phases. The application with continuous security and a DevOps approach, potentially and hopefully an application with a security vulnerability would get picked up by that automated process, and the application won't get anywhere near production because we picked it up and it's halted the process of putting that application out there. Integration with development, often separate from development, tightly integrated with development and deployment processes when looking at continuous security. Threat response is reactive, often post-breach. With continuous security, it's proactive, identifying vulnerabilities before they can be exploited. With traditional approach, coverage, focused on key systems, not always comprehensive. So the more manual it is, the more likely the steps are going to be missed, or it's not going to be reviewed as thoroughly as what it might be with automated processes. Finally, we've got stakeholder involvement, limited to security teams. So in our isolated teams in a traditional approach, they're taking care of security. With continuous security, it's collaborative. It's between developers, ops, and security teams working together. Next, we have continuous monitoring, and this is about providing persistent oversight and analysis of operational functions of software applications and infrastructure. Anomalies and issues are detected and addressed promptly. So continuous monitoring is, of course, important when we're automatically rolling out changes multiple times per day. There's risks, although doing them in smaller changes than a traditional approach probably carries less risk because we've got smaller changes. When we have an issue, we've got a good idea of what it is. But ultimately, with a traditional approach, we've got periodic checks and maybe scheduled reviews. With a continuous monitoring approach, we've got real-time monitoring of applications and infrastructure. With automation, primarily manual, with some automated tools. In a traditional approach, automated tools with real-time alerts. With a DevOps approach, feedback timing is scheduled or after issues, whereas continuous monitoring, it's immediate and alerts on anomalies. Scope of monitoring is selective with a traditional approach. Continuous monitoring is automated, and again, that allows us to be very comprehensive, covering all systems and applications. The response is sometimes or typically reactive with a traditional approach, where it's proactive with a continuous monitoring approach. And this is another thing that's limited to the ops, a single team, the ops team, with a traditional approach. But again, with continuous monitoring, again, we're bringing operations and developers and these people with different skills together to collaborate with continuous monitoring and the DevOps approach. We've then got continuous feedback, and this is the ongoing process of collection, analysing and acting on feedback from stakeholders. An iterative feedback loop that ensures product meets users and user needs and expectations. So all of the processes around DevOps enable us to respond better to user needs, business requirements, the expectations of users. And I'm going to get more into Agile, the Agile methodology, project management methodology shortly. But ultimately, when we've got that big, long project, those sequential stages of development, testing, security, deployment, it makes it very difficult to respond to the change in requirements, change in the market, competition on the market. It makes it very difficult to adapt our application. With continuous feedback and the way we're working with Agile, we're sorting our requirements and we're delivering in much smaller cycles, and we can add changes of requirements into the next cycle, potentially if it's a priority. So we can just respond a lot better to requirements, user needs, and changes in the environment. With traditional approach, we've got periodic feedback, often post-release. Continuous feedback, we've got ongoing feedback throughout the development lifecycle. Primarily scheduled again in traditional approach, incorporated into the next release or version. Often general and high level for feedback scope. Stakeholder involvement is limited to reviewers and select users. Response time is longer due to infrequent feedback cycles. When we haven't got it's not built into our processes and our workflow to get feedback, then the response time is going to increase because we need to get the people involved, and we're getting them involved at random times, and it's not built into our workflow, our daily job. So then with continuous feedback, it's an ongoing feedback through the development cycle. We have multiple sources of feedback, user forums, real-time user analytics. We can rapidly integrate into the project, possibly in real time as well, so we can adapt really that quickly to feedback with a DevOps approach. Okay, so then we have continuous documentation. It's another big shift with DevOps, evolving and updating documentation concurrently with the software development and deployment. So as we're developing the application, we're doing the documentation updates alongside the changes that we're making to the application. This is in contrast to a traditional approach where we typically do a big design up front, or we might update the design at the very end. In DevOps approach, we're doing this continuously again, another continuous process. So to point out some examples here, relevance is a good one. You can see as well that it can become outdated rapidly when we're doing the documentation infrequently. It's likely to become outdated very quickly, and then you'll probably find that people don't refer to the documentation very often because they don't know if it's still accurate. So that can often stop people from just reading the documentation at all. So then, finally, the final continuous concept is continuous improvement, and this is about improving the processes, products, and services, and small regular improvements. So we take the example of frequency. Traditional approach, we've got periodic reviews and scheduled improvement phases. Continuous improvement is ongoing continuous evaluation and refinement. Basis of improvement is historical data and post-project reviews. So with a traditional approach, we might do something known as a lessons learned, and this is where we look back at the project at the end of the project and we look at what went wrong and the reasons why, and this will go into a spreadsheet often and get stored on the intranet and not necessarily looked at again by anyone. So that has problems in its own right. It's just like the documentation. You can go through that process, but it doesn't mean that people will read it. Whereas with continuous improvement, It's real-time data, feedback, and iterative, and it's another thing that's built into our day-to-day working processes. Stakeholder involvement is limited to management certain teams. Collaborative with DevOps. Feedback loop longer, often post-project. DevOps is short and iterative, leading to rapid refinements. Scope is broad with traditional and less frequent, smaller incremental changes. So you notice with all of these concepts, they're all around doing things in smaller chunks, more frequently, and responding to changes in the environment and being adaptable. And this is the basis for Agile, which I'm going to go into in the next slide. Okay, so let's drive more into the Agile methodology, and this is focused around the procedure of how we go about our projects. So let's start by looking at a waterfall approach. And then in the last slides throughout this presentation where I've been referring to the traditional approach, this is referring to what's known as the waterfall methodology. And this is an approach to project management where we have sequential phases and we work from the first phase to the next phase, to the next phase, to the next phase. Each phase must be completed before we can move on to the next phase. If something causes us to go back to a previous stage, if, for example, the requirements have changed, so we've got number 1 on the list, requirements gathering. If we get to the design and then the implementation and the requirements change, we've got to go back to the requirements gathering, and all of the phases, the coding must stop. Testing, of course, we can't get to the testing phase because we can't implement it because we haven't got the requirements. So this is how the waterfall approach works. We work from one phase to the next, to the next, to the next. And I'm going to give some more examples of the problems that this methodology causes, but this is the traditional approach. So then we have the Agile methodology, and throughout this presentation where I've referred to DevOps and the continuous concepts, this is around Agile. So you can technically have DevOps or components of DevOps without using an Agile methodology, but these really go hand in hand. Agile is an alternative to Waterfall, and it's focused on the development process of software. It's about that iterative approach to product development. It emphasizes adaptability, iterative development, and continuous feedback from stakeholders. And we deliver through 2 to 4 week sprint cycles of ceremonies. So whereas with a waterfall approach, we've got those 6 stages. This might take, for example, 6 months. We might spend 2 weeks doing the requirements gathering, 2 weeks doing the design, 4 months doing the coding, 1 month doing the testing, 2 weeks doing the deployment, etc. So if we get through our project, we're 3 months in, the requirements change, we've kind of got to go back to the beginning, do the design changes, and then we can continue with the development and go on to the next stages. So Agile kind of works in mini project cycles of 2 to 4 weeks, and these are called sprint cycles or iterations. So at the beginning of each cycle, we hold certain meetings with the entire team. We have, for example, the sprint planning, and this is where we look at all of the tasks, we look at the requirements that have been defined by the stakeholders, and we choose what we are going to work on for the next 2 to 4 weeks in this sprint, however long the sprint is, between 2 to 4 weeks. So we do the sprint planning, we choose our priorities, we commit to delivering on these requirements and developing the product to meet those requirements within that sprint. And tasks should not be moved from sprint to sprint. Number one goal is to finish that activity by the end of the sprint. Halfway through the sprint, we have what's called a backlog refinement, and this is where we reevaluate the priorities. Do we need to move stuff out because priorities are down, have changed? And then finally, we've got the sprint review, customer demonstration, and retrospectives. So sprint review is where we demonstrate what we've delivered during that sprint. A customer demonstration is where we show working software. So another key goal of every sprint is to deliver working software by the end of the sprint. And we should be able to demonstrate that to the customer or the stakeholders and get their feedback at the end of every sprint. This is very different from waterfall, where we've got that initial 2 weeks requirements gathering and the 2 weeks documentation. Now we've got the 4 months of development. The stakeholders aren't going to see the product until the very end. And that carries a lot of risk, because if something's been misunderstood during the requirements gathering and we've done all of that work and we've got to the end and it needs to be changed, then it could be very expensive to go back and make changes. Finally, retrospectives is part of the continuous improvement. We typically hold a retrospectives meeting, and this is between everyone on the team, and we evaluate how the sprint went. How can we improve our processes? This is where a meeting where we can be honest, direct and honest with each other about our processes and how we can improve them. Okay, so this is the final slide, and I think I've covered a lot of this in the previous slide, but this is a side-by-side comparison. So I'm just going to give a quick summary. So waterfall, we get those requirements up front. Adapting to change throughout the project is difficult, costly and time-consuming. With Agile, it welcomes change. Thanks to those sprint cycles, short sprint cycles, where we can adapt to the user requirements, we're choosing our priorities at the beginning of each sprint. If there's a big issue with something that we've implemented and it's not right, we can fix it within the next sprint. So we've got the ability and the adaptability, and that's where the Agile name comes from. Feedback, so stakeholders don't see the product until the end, as I mentioned. Misunderstandings or incorrect assumptions are not discovered until very late in the project. If there are big misunderstandings and big mistakes have been made, then that could be costly. Agile, through those sprint meetings and the customer demonstrations, we're constantly getting feedback. At the end of every sprint, we're getting stakeholders seeing the current version of the product and making feedback. And then risk, such as design flaws, may not be discovered until the very late in the process. Similar thing again to the feedback. With Agile, it's continuous, frequent feedback helps to catch risks early. Time to market, so this is quite a big one as well. So with a waterfall approach, we've got that 6-month cycle. If we've got that 6-month project, we're not going to have the product until the very end, and we'll have the whole product at that stage. What we're doing with an Agile approach is we're iterating upon the application. So after one sprint, we may not, we won't have the entire product by any means. We're going to have a very initial, maybe minimal viable product. And in later sprints, we're going to continue to iterate upon that, iterate, and evolve the product closer to the full product. Ultimately, what this means is with a waterfall approach, we're not delivering anything for 6 months. With an Agile approach, we're delivering something and improvements on 2 to 4 week cycles based on the size of the sprint. Then we have teams. Sequential nature means that teams hand off to each other and work in silos. So the operations teams, when we've got those waterfall phases, when we work through the requirements gathering, development, operations, testing, This is moving between different teams, and these teams are working in isolation. So once the developers are done and they pass it on to the next stage, the testing stage, that might be done by an entirely different team. And the people that developed it aren't being involved in the testing. This is in contrast to Agile, where we have cross-functional teams, and they work in collaboration throughout the whole project and throughout the whole delivery. They work those meetings that we have, the sprint planning, backlog refinement, sprint review. The whole team joins them. Operations people, dev people, security people collaborate in those meetings. And finally, we've got documentation, extensive upfront documentation for waterfall that may become outdated and or unread. Agile prioritizes working solutions over comprehensive documentation. So that concludes my presentation on DevOps and Agile. Ultimately, DevOps is a process or a concept of culture, processes, and tools to iteratively deliver software. And we have these continuous concepts that facilitate us in these processes. These are all around small incremental changes, continuous feedback from users and stakeholders, continuous alignment, and adapting to change that a traditional approach wouldn't allow us. And finally, we have waterfall and agile, and we can see the differences between that traditional approach not being able to adapt to requirements compared to agile, where we're getting continuous feedback, we're continuously demonstrating the product to the stakeholders, which significantly reduces the risk and the potential cost impact of something going wrong during the project. Thank you for watching.